Good morning, Prep 3. Today we are going to make a revision about some types of problems inside your final revision sheet in your booklet and some questions in what happens. So please pay attention and open your booklet on page 140. I will answer. Yes, we already answered the problem until number 6. Today I will start in number 7, so please pay attention. In number 7 problem, he asks you about, or he tells you that a person moves in a path A, B, C, D, E as shown in the figure. Okay, he covered a distance of 10 meters northward, so please pay attention. We can determine the distance here from A, then B. This distance is about 10 meters. Then yes, he covered this distance in 2 seconds. Then he covered 30 meters eastward in 10 seconds from B to C here, and followed by 40 meters southward in 8 seconds. So this distance from C to D, this is D, 40 meters in 8 seconds. Finally 30 meters westward in 5 seconds. 30 meters westward in 5 seconds. So here the starting point is A and the ending point is E. Again, pay attention and look at the figure. Pay attention. He will ask you about this problem without drawing. You must draw your problem. Okay. Number 7. A person moves in the path A, B, C, D, then E as shown in the figure. He covered a distance of 10 meters northward. This means from A to B 10 meters in 2 seconds. Then he covers 30 meters eastward from B to C in 10 seconds, and followed by 40 meters from C to D southward in 8 seconds. Finally 30 meters westward in 5 seconds. This means that from D to E. Number 1, he asks you to calculate the displacement. Judana?
Hello.
Hello? I can hear you well. It's fine.
Can you hear me?
Yes, I can hear you well. Okay, Judana. Okay, we answered the problem, page 140, number 7. Okay, number 1, he asks you to calculate the displacement. And we know that the displacement is the shortest straight line between the starting point and ending point. And the starting point here is A. This is starting point. And the ending point here is E. The distance from A to B equal 10 meters. The distance from A to B equal 10 meters. He wants to calculate the displacement, so please pay attention. The length from E to B equal the length from C to D. From C to D. Again, the length from E to B equal to the length from C to D. Then the distance from E to B equal 40 meters. The distance from E to B equal 40 meters. But he asks you about the displacement. So the displacement is the distance between the starting point, which is A, and the ending point, which is E. So can you calculate the distance between A and E? Hey, Judana, can you calculate the distance? 30. Excellent, Judana. Judana, I can hear you, so you can answer inside your mic. Okay? Okay. The distance here equals 30. Excellent, Judana. I will make 40 minus 10 equal 30 meter. Is there any problem here? Okay, there's no any problem here. Thank you, Judana. Number 2, he asks you about in which part the person moves with the least speed. In which part the person moves with the least speeds. Here I need to calculate the speed in each part. Let's go to calculate the speed in each part. Can you calculate the speed from A to B? Yes, the speed equal distance over time. The speed equal distance over time. Yes, no, Judana, we need to calculate the speed in each part firstly. So please pay attention with me. Can you calculate the speed from A to B? From A to B? Why? Can you hear me now? Okay. I can calculate firstly. I need to calculate the speed in each part. Number 1, I will calculate the speed from A to B. The speed from A to B equal distance divided time. The distance here equal 10 meter divided 2 seconds. 10 meter in 2 seconds. He tells you that he moves from A to B in 2 seconds. Then 10 divided 2. So the speed here equal 5 meter per second. From A to B equal 5 meter per second. Let's go to calculate the speed from B to C. From B to C, 30 meter. He covers 30 meter in 10 seconds. So 30 divided 10 equal 3 meter per second. Okay, let's go to calculate the speed from C to D. From C to D, 40 meter divided 8 seconds. Can you calculate 40 divided 8 seconds? Calculate it, Judana. 40 divided 8. Yes, the speed will be 5 meter per second from C to D. Then finally we calculate the speed from D to E equal 30 in 5 seconds. So 30 divided 5 equal 6 meter per second. So now can you tell me which part the person moves with the least speed? Which one is least speed here? From A to B, no. Again, from A to B, no. From A to B, pay attention, from A to B, the speed equal 5 meter per second. From B to C, the speed equal 3 meter per second. From C to D, the speed equal 5 meter per second. From D to E, the speed equal 6 meter per second. So the least speed from B to C. From B to C. If you calculate the speed from B to C, I will divide it. Yes, 30 meter divided by 10. 30 from B to C, 30 meter divided by 10 seconds. So the speed will be 3 meter per second, and this is the least speed here in BC. Okay? Is there any problem here, Judana? Okay. Let's go to see the next problem. Problem number 8. Problem number 8. A car moves. No, sorry. Problem number 8. Two race cars. Okay, two race cars. The first car. Number 8. Two race cars. The first car moves at the speed of 80 km per hour, while the second car moves at the speed of 120 km per hour in the same direction. Calculate. Number 1. The relative speed of the first car relative to, pay attention, relative to an observer standing on one side of the race road. Pay attention. We said that the relative speed relative to an observer standing, so this is equal the real speed, and here I need the relative speed of the first car. Do you know the relative speed of the first car relative to an observer standing? Excellent. The relative speed here equal the real speed of the first car as the observer at the rest. So the observer see the real speed of the first car. Then the relative speed here equal 80 km per hour. Excellent. Number 2, the relative speed of the first car relative to the passenger in the second car. So this is the second car, the relative speed of the first car relative to the passenger in the next car or the second car. Can you write the answer? Yes, exactly. Both of them moves in the same direction, so we will make V2 minus V1. Yes, 120 minus 80, so the answer will be 40 km per hour. Okay, now let's go to see the next problem. Number 9. Problem number 9. A car moves with the speed 80 meters per second if the driver used brakes to decrease the speed, so it decreased by 2 meters per second power 2. Pay attention about the measuring unit here, meter per second power 2. So number 2 is the value of acceleration. And he said that it decreased. So the acceleration here will be with a negative charge. Calculate its speed after 12 seconds. So this is the time here from using the brakes. Again, pay attention. A car moves with the speed 80 meters per second. So this is V1. This is considered V1. If the driver used the brakes to decrease the speed, so it decreased by 2 meters per second power 2. So this is the value of acceleration, and he said decreased, so the value will be with a negative charge. Calculate its speed after 12 seconds. So this is the time from using the brake. Okay. Can you tell me what is the law of acceleration? The law. Acceleration equal What about the law of acceleration? Acceleration equal Yes, acceleration equal V2, which means the V final minus V1, which is the V initial, divided by the time. Here I will substitute the value of acceleration and the value of V1 and the time to calculate V2. Now V2 equal acceleration multiply time plus V1. Okay, V2 now equal acceleration multiply time plus V1 from the rule. the acceleration equal -2. Here, yes, the acceleration here equal -2. Pay attention, not 2. The acceleration here equal -2, as he said, decreased. So -2 multiply time, which is 12 seconds. Yes, plus V1, which is 80. Can you calculate it? Okay. Number 10, a car moves from Banha to Cairo, a distance of 40 kilometers in 30 minutes. Pay attention to the time here in minutes. Then it returns back from Cairo to Banha in the same time, which is 30 minutes again, and in the same distance, which is 40 kilometers. Okay? Calculate in kilometer per hour. Pay attention. Calculate in kilometer per hour. Number 1, the car velocity from the beginning to the end of the journey. The car velocity from beginning to the end. Can you answer? So please pay attention. He told you that he returns back from Cairo to Banha, and the velocity equal displacement divided by time. Displacement, not the distance. And the displacement here equal? Yes, the displacement here equals 0, as the starting point is the same of the ending point. So the velocity also equal 0, as the velocity equal the displacement divided time. So 0 divided time equals 0. Okay? Let's go to answer the next one. He needs you to calculate the average speed of the car during total time. The average. Excellent. The average speed of the car during total time. So the average speed here equal total distance divided by total time. Can you calculate the total distance? Okay, let's answer it step by step. Step by step, please. So the total distance equal 40 plus 40, as he travels from Banha to Cairo, then from Cairo to Banha again. So the total distance equal 40 plus 40 divided by total time 30 minutes plus 30 minutes, but he needs you to calculate in kilometer per hour, so I must change the time from minute to hour. I must change the time from minute to hour. The total time here equals 60 minutes, right? The total time here equals 60 minutes. So 60 minutes equal how many hours? I know there is no place here. Pay attention. So the average speed here equal total distance divided by total time, and the total distance here equal 80 kilometers, and total time equal 60 minutes, but he asks you to calculate it in kilometer per hour, so I will change 60 minutes to hours. 60 minutes equal just 1 hour, so the answer will be 80 divided 1 equal 80 kilometers per hour. Okay, let's see the next one. So number 1, what would happen in the following cases? In your booklet, page 146, incident light ray falls parallel to the principal axis of the concave mirror. When the incident light falls parallel to the principal axis, so it reflects, and I said reflects as he asks you about the mirror, so I must say reflects. So the answer will be it reflects, passes to the focus. It reflects, passes to the focus, right? Number 2, the light rays passes through the optical center of the lens. The answer of question number 2, when it passes through the optical center of the lens, so the light ray passes without refraction, and I must say refraction here as he asks you about the lens. Okay, number 3, increase the diameter of the eyeball from the normal state. Pay attention, increase. Excellent. When he tells you increasing the diameter, increase, so the answer will be the opposite, and this causes short-sightedness. This causes short-sightedness. Number 4, so now pay attention, he asks you if the body cuts the same distance in half time, and we know that there is an inversely proportional between the speed and the time. When the time decreases to the half, so the speed will increase to the double, so the answer here is speed increases to the double. Okay, let's go to see the next question. Number 5, an injured liver or cutting a part of it. Injured liver or cutting a part of it. What happens when cutting a part of the liver? So the answer here will be the liver will divided mitotically to compensate the missing part. The remaining cells undergo many mitotic division to compensate the missing part. Okay, we took that the main function of mitotic division is compensating the missing part. Number 6, what happens to the displacement of an object when it returns back into starting point? We know that when the body returns back again to the starting point, so the displacement here equal 0. Number 7, when rupturing of sporogenium. What happens when rupturing of sporogenium? Here the answer will be produce a large number of spores that divided mitotically. Okay, number 8, less convexity of the eye lens. Less convexity of the eye lens. Here also I will answer the opposite, less. So this will cause short-sightedness or long-sightedness? Excellent. Occurrence of long-sightedness. Occurrence of long-sightedness. Number 9, page 147. Number 9, approaching a huge star to the sun according to the crossing star phenomenon. The star here attracted the sun to it. The star attracted the sun to it, leading to a great expansion in a part of the sun. Leading to a great expansion.